Alright, in my previous video I spent a whole hour ranting about the things I've been doing lately in terms of progressing towards the goal. This video I'm going to actually be talking about what needs to be done in terms of the actual product, which makes this video a little less motivational and probably more boring, but it is all just to hold myself accountable as we go along. Now, obviously, the things I have to still do is render the icon, the text, and in the previous video, I showed the 3 sub-goals that are needed to achieve that. I did not include the rendering a curved line, though. But let's talk about something very specifically. Here's what, by the way, I'm going to limit myself. As per my videos, I'm not going to be expressly going in depth about the complete future of the application. I'm only going to be talking about specifically what you're seeing on screen and what the point of it is. So, for people, I know these videos have not been popular about the actual examples of digital signal processing, but that is what I'm working on. And digital signal processing is nothing more than processing a signal, which makes it sound very fancy, but you have data coming in, you want to change or record that data as fast as possible. So in this instance, we're talking about sound. Now, I want to be able to create a signal, modify that in a way, and output it to a speaker. In other words, very simply said, I want to make music or sound. And you do that by creating a synthesizer. And a synthesizer, I'm going to repeat myself, is nothing but something that creates a signal, modulates it according to parameters which have a certain behavior associated with it, and then outputting it. And this part is very important because it's very abstract, but if you have like a pitch adjustment, that's a particular transformation to the input signal. And if you have harmonics, that is, if I'm saying it correctly, multiple signals overlaid on top of each other, which can also be represented as a mathematical function to a single signal. And I say signal because I'm basically just talking about a number. So a number comes in, the number is changed, the number goes out. And you can represent that as a series of transformations. Now, the simplest way to do that is to go in your code to make an audio buffer and to do a for loop over the buffer and change the values according to some desired outcome, and then return the buffer and send that to your audio framework like N-Audio or whatever. But once you start adding controls to your synthesizer, pitch, harmonics, and all of this stuff. Now, I'm running out of examples, by the way, don't quote me on that. Once you keep adding these, each of these also needs parameters. How do you want to modulate it? How do you want to change the pitch? How do you want to change the phase? How do you want to change the incoming wave? And your function is going to grow exponentially. This is problematic because at some point you're going to have so much data into something that really only requires maybe 2 or 3 features, and your synthesizer becomes like huge. So my goal is simple. I want to be able to create a synthesizer that can do basically any transformation that you can imagine, and the output is going to still be efficient. So you want to keep track of the transformations that are used and then turn that into a function that you can actually call. And it turns out, using link expressions, that's very possible. You can literally build code to build code. Now, how can we do that in a way where people can actually use it? Well, here's the example, what I came to. It's a static sine generator. And, well, it's a graph. And apparently Unreal Engine also does this. I didn't know they would steal my business secrets, but they have proven that this works. So you guys don't have to think this is such a crazy idea. The way it works is you define a bubble called like an input, and then you connect that bubble to some transformative or modulatory functions like multiplication, and then you give it an output. So in other words, a sine wave comes in, it's multiplied by 2 in this case. Let me zoom in because you guys probably can't see that. It's multiplied by 2, which makes it louder, and then, or higher pitch. I think it makes it louder. I think if you multiply a number, it just makes it louder. And then Yeah, because pitch is like how fast something oscillates, so it's a more complicated transformation. But anyway, then it goes to output left and output right because I have headphones. Unfortunately, I'm not rich. I don't have a Dolby 5.1 or 7.1, whatever they call it these days, speaker sets in my living room. So for this particular canvas, this Figma design, only output left and output right. Now, if you have these building blocks, multiplication, addition, division, and you have some sort of state tracking, what you can do is add more bubbles, which basically form complicated transformation of the signal. So if you could represent, for instance, I'm not saying this is true, but if you could represent making something sound more wet by connecting multiplication to division to plus, you could graph that out and you have this particular synthesizer knob dial inside of this graph area. And with this setup, it's not perfect yet. There's a lot more that needs to be added to it, but you can basically program the functions of the synthesizer, and then what you do is you take the input and output and you turn it into a link expression, which is then compiled down to an actual almost like machine level code, like very low level, which can be executed as fast as a regular synthesizer optimized for performance would. So you are building the functions of the synthesizer. Now, I'm not going to explicitly mention where this will go after that, but you can look at my channel, my first few videos that I still have public, as to what I'm really working on and why that's very interesting if you're into this stuff. Now, there's problems to be solved that I'm not going to mention, but the reason it's called a static sine generator is because you still need a way to determine phase. It does not do anything with time or state tracking. There's no input sources like other sound effects. The basic design I first want is to be able to connect bubbles just from first to last and again output. Is this interesting? Just to spoil a little bit, is this interesting for a person to make music or sound with? Absolutely not. But what is this useful for? It is useful to represent, to make it humanly readable what a machine would output in order to represent a specific sound, if you make it flexible enough. That's all I'll say.